In this video, we're going to take a bit of a diversion from Pressman and look at Chapter 2 of the book UML Distilled by Martin Fowler. Recall that when we talked about Agile development, we mentioned that about 20 proponents of so-called lightweight development processes went on a retreat to Snowbird Resort in Utah to come up with the Agile Manifesto. Well, Fowler was one of the people there, so he's quite well known as an advocate for Agile methods. Fowler is also well known as the father of refactoring, where the object is to strengthen the design of your code without modifying its functionality. Let me just say a few words about the book UML Distilled here, because this is definitely one of my all-time favorite software engineering books. The book is super thin, but it's packed with information, mainly about UML, but also about software development in general. The chapter we're going to look at today doesn't even mention UML. It's all about the software development process. So here's one of the things I absolutely love about this book. Since it's written from an admittedly biased perspective, unlike Pressman, who at least tries to give the appearance of being unbiased, Fowler doesn't worry about making sweeping claims. And as long as you know where he's coming from, those claims can often help simplify your understanding of the software development landscape. For example, he starts off this chapter by describing a distinction between the waterfall approach to software development and the iterative approach to software development. In the waterfall approach, you break down a project based on activities involved. In the iterative approach, you break down a project based on subsets of functionality. Each iteration does all the activities, but an iteration is going to deliver a subset of the total requirements. And from my perspective, the most interesting thing about this distinction is that's all there is to it. And from Fowler's perspective, that's all you need to understand about software process models. These quotes drive this home. Iterative development has come under many names: incremental, spiral, evolutionary. So he's grouping all of these different methodologies we've looked at under one umbrella. Recall that Pressman categorizes the spiral model as a kind of evolutionary model, and the incremental model, according to Pressman, isn't even that different from the waterfall. Its requirements must still be known in advance. Again, that's according to Pressman. But Fowler is saying, ignore all of those distinctions. People continue to argue about the details, but those details aren't what's important. The important thing is, are you breaking up your project in terms of activities, or are you breaking up your project in terms of subsets of functionality? Bam, Occam's razor, problem solved. Those are the only two things you need to worry about. And here's the punchline. You've got waterfall and you've got iterative. Don't use waterfall, do use iterative. He uses some colorful language to say that here. By the way, use iterative only if you want your project to succeed. That's a classic Fowler quote. Okay, so now we obviously know where Fowler's sympathies lie. He spends the rest of the chapter explaining some of the features of iterative development. A key feature, and we've seen this in the Agile processes we've looked at, but it's really emphasized by Fowler here, is time boxing. The principle is simple. An iteration must be a fixed length of time, and nothing that happens is allowed to change the delivery date of your working software. So you must deliver software that works, and you must deliver it on time. But wait a second. What if you're halfway through your increment and you realize, uh-oh, I've completely underestimated the time it would take me to do this. There's no way I'm going to be able to deliver it all in 2 weeks. Well, when your increment is time boxed, the solution is easy. If you can't deliver requirements A, B, and C in 2 weeks, then you deliver requirements A and B in 2 weeks. In other words, you have to slip functionality rather than slipping the delivery date. Now, in practice, it should be said that this doesn't really happen that often. And the reason is, by keeping the length of the increments so small and having experienced programmers around, it's much easier to estimate how long something's going to take to implement. A key concept in iterative development is rework. Part of adding functionality to existing code, which is something you'll be doing a lot of in iterative development, means changing portions of that existing code. And here's some things that Fowler suggests can make those changes more manageable. Automated regression tests, refactoring, and continuous integration. Let's start with regression testing. Regression tests are automated tests that allow you to detect bugs that were introduced when you modified the code. Regression tests are most often done with unit tests, though other forms of tests can be involved as long as they can be automated. We're going to talk a lot more about unit testing later, but for now, think of a unit test as a test for all the methods in an object-oriented class. If you write a class called Airplane, you're going to have a test class called Airplane Test. Suppose you do that and you get it to the point where all the tests in Airplane Test pass. Since unit tests can be automated, you can simply run Airplane Test and get a yes, meaning that the tests have passed, or a no, meaning that there was at least one test in Airplane Test that did not pass. Suppose all your tests pass, and then you're asked to create an airplane controller class. It's conceivable that when you create the airplane controller class, you might have to modify the airplane class slightly. Maybe you need to add another field or a method to it. If you do, you want to make sure that you don't break the portions of the airplane class that already work. So you periodically run airplane tests to make sure that this doesn't happen. If you use this technique for every class you create, you'll develop a suite of regression tests that can be automated. As a final note, Fowler says that ideally, the amount of testing code you create should be roughly equal to the amount of production code that you create. Based on my conversations with students who are working as developers, this seems like an ideal that may not be achieved very often. Seeing as Fowler wrote the book on refactoring, and the book is called Refactoring, it's really no surprise that refactoring is a central part of managing rework. Refactoring is strengthening the design of your code without changing its behavior. What are some examples of this? The simplest example is the rename method refactoring. If you have a confusing name for a method and you change the code by giving it a name that others can understand, then you've done a refactoring. You haven't affected the code, but you just made it a little bit more understandable and a little bit more maintainable. Refactoring can also be as complex as introducing a design pattern so that your code can be updated more easily in the future. We'll talk more about design patterns later in the course. The point about refactoring is that from a developer's perspective, the code is much easier to work with after a refactoring. From a customer's perspective, what the software does has not changed at all. The third thing that aids in managing rework is continuous integration. Continuous integration is an automated build process that's used to keep a team in sync. At the heart of this build process is a version control system. A version control system is a tool that automatically keeps track of the changes made to the code by the developers. Often, it involves a central repository where the official code resides, and individual developers check out their own copies of the repository. When a developer wants to make a change in some code in the central repository, they first ensure that their repository is up to date. Then they make the changes they want. If they're creating new classes, they're going to write unit tests for them. Once they made the change, they have to check their changes into the main repository. A good build process will automatically run a suite of regression tests to ensure that their changes haven't broken anything. Okay, so those three ways of managing rework are very important in iterative development. Now Fowler discusses something unusual about the waterfall model. He indicates some of the major problems with the waterfall model. It's hard to tell if a project is on track, working software is not produced until the end, and perhaps most seriously, the waterfall model can't adapt easily to changing requirements. Despite this, Fowler says, the waterfall model remains common in industry. Is this really true? If so, why is it true? Before I give you Fowler's answer, see if you can come up with some of your own. Based on what you know of the waterfall model, why do you think it would be common in industry? Ready? What did you come up with? A good answer is that management likes the waterfall model because of its predictability. It's easy to estimate things and assign costs. And if things go wrong, well, you can just cancel the project or do a better job of estimating. Interestingly, Fowler gives a very different answer. He claims that people often think that they're doing iterative development, when in fact they're doing waterfall development. For example, if someone says, we're doing one analysis iteration followed by 2 design iterations, well, that means they're breaking their project down by activities rather than subsets of functionality, so they're doing waterfall. And what if somebody says, this iteration's code is very buggy, but we'll clean it up at the end? Well, if they mean they'll clean it up at the end of the project, then they're not doing iterative development. The end of the iteration is when that iteration's code should be working. You don't deliver buggy code. As to why it's so difficult for people, especially management, to buy into iterative development, Fowler makes a distinction between predictive planning, which conforms to waterfall thinking, and adaptive planning, which conforms to iterative thinking. In predictive planning, step 1 is to come up with plans, and step 2 is to execute those plans. Step 1 is the stage that's hard to predict, but once you've done that, the second stage falls nicely into place. Customers want predictability. They have only so much money they're willing to spend, and they don't want to go over budget. Also, they want to know how long something's going to take, and they want to know, in the end, what they're getting for their money. So, as Fowler admits here, it's very frustrating if you don't know these things. But he also suggests that in some projects, all of these things may not be predictable. One of the things that causes trouble for predictive planning is requirements churn. Changes in requirements in the later stages of a project. This is something that's very common in projects. There are 2 possible ways to try to deal with requirements churn. One is to try to prevent it by putting more effort into the initial requirements phase of the project. Fowler thinks this approach is doomed to failure. The alternative, he suggests, is not to use a predictive plan. Rather, he would suggest using an adaptive plan. If you read through some of the features of an adaptive plan, you should see how they make sense in the context of agile development. However, think of these things from a customer's perspective. You're trying to manage a business, balance your budget, and deliver a product. Your software developers tell you they'll take on the project as long as you realize that 1, predictability is an illusion, 2, change is constant, 3, we can control the project, but we can't predict it, and 4, nothing is going to go according to plan. Then before you leave, they turn around and say, oh yeah, we almost forgot. You can fix the budget and the delivery time, but we can't tell you exactly what we're going to be able to deliver. Given all this, you might see why adaptive planning and, in turn, iterative development might be a hard sell to the customer. And on that note of caution, we'll conclude this module on agile development. In the next module, we'll talk about requirements engineering, and we'll look at what kinds of things go into gathering the requirements for a project. I'll see you there.